In our first session, we explored the concept of distributed AI. We introduced this understanding of pushing AI closer to end users and the creation of data, with the ultimate goal of improving customer experience and faster decision making, all whilst upholding sovereignty as and when required. Now, this all sounds great in theory, but how does it come together in reality? And in this second session, we're going to explore this through the customer lens. To help us on this journey, let's imagine a fictitious customer, Acme Healthcare. Acme is a world leader when it comes to digital patient care. They have deployed a global platform today, which successfully serves users across all three regions. And they've primarily based this on co-located infrastructure. As I mentioned, they operate across EMEA, APAC, and EMEA. Now, for simplicity, we're just going to draw out one of these regions. And their primary interface for customers today is their web-facing application. Now, a patient of Acme will log in through this application and get access to doctors and specialists, as well as any of the health records that Acme has on behalf of them. Again, for sovereignty and compliance reasons, they replicate this infrastructure across all three regions, essentially ensuring that this data remains in sovereign borders. Now, due to the explosive growth of this application, the number of users is far outweighing the available doctors and specialists. So Acme is a victim of their own success. It's a lot harder to onboard new doctors and specialists, and so now they're looking at ways to augment their existing platform capabilities. And Acme is looking to do that through the introduction of AI. Acme has this goal to test an AI doctor, essentially a system that can augment the capabilities of their human specialists in an attempt to free up those resources for patients who actually require that level of interaction and care. And their goal is to build this AI doctor to understand the business of Acme. In that case, it should be business aware, as well as understand the patient context. This patient might have a long history with Acme, and the AI should be able to understand that. Now, to build out Acme's current landscape a little bit more, their core services do live in co-location, but they're also heavy users of hyperscale cloud environments for ancillary services. So they make use of AWS, GCP, and Azure for services that help augment this platform, as well as storing some information about their overall business as well. Now, given Acme wants to evaluate how this can deliver real ROI to their organization, they're essentially in a proof of value phase. And so they don't want to go out and buy expensive GPU infrastructure to start to test this thing. And whilst it's true they could use their existing hyperscale cloud relationships, Acme turns to a new wave of cloud, the neoclouds. Now, this is a relatively new term in the IT landscape, but essentially neocloud is new cloud. These are the guys who are specializing in AI-centric services. They're standing up sets of global infrastructure simply to help customers with their adoption and journey in AI. And in this case, let's assume Acme taps a provider like Nebius, a full-stack AI. Now, to start to build this model, and as we saw in the previous session, it all starts with data. Acme needs to funnel all of the data that will help this model understand their business context into this environment. And so that will require heavy amounts of interconnection that's both high bandwidth, because these are generally very large data sets, low latency, and secure, given the nature of this data. Now, even though we're connecting up some of these electronic health records, we need to ensure that this is non-sensitive information. We don't want to be training on personal information from the patients, although there could be good business context in these data sets. And so we can bring all of that data into a provider like Nebius, where we can stage it, essentially aggregating all of that data like we saw in the previous video. We have the tooling to pipeline that data, essentially transforming it into something usable that we can train upon. And then finally, get access to the latest hardware or latest generation of GPUs to train a model. Now, the goal of this step, as we saw, is to come up with this business-aware AI doctor, a model we can use inside of our existing infrastructure. So again, Acme's on this journey to prove the value that this thing can do what it needs to do. And so in injecting it into their existing infrastructure, building or procuring GPUs to do this could be cost and time prohibitive, especially whilst they're still trying to understand what value this will actually deliver. And so much like their use of neoclouds with Nebius, Acme decides that they're going to use a specialist inference-as-a-service provider like Grok, who can provide the low latency infrastructure needed to host this model in close proximity to their existing infrastructure. And so with the help of a provider like Grok, we can inject this AI doctor into our existing landscape. Now, as I mentioned, this AI doctor really needs two things. One is to be business aware, which we've successfully done. We've trained on all of the business information. It understands Acme as good as any internal employee. But we're still missing this patient context. Noting, of course, we only trained on non-sensitive information. We didn't want to put patient information into the model, as that would increase our attack surface and the potential for data leaking. It would also potentially breach our compliance and regulatory frameworks that we need to operate under. And so what Acme needs is a way to inject this patient context into the model. Now, this is not an exhaustive AI session on all the different architectures possible, but what Acme has chosen in this case, at least for their proof of value, is to use RAG, so Retrieval Augmented Generation. Essentially, the ability to take their existing health records, embed those into a vector database, and use that to supply patient-aware context back into the model. And so Acme stands up this infrastructure in their colocation environment. Essentially, they use existing database with embeddings to stand up this new vector database. And essentially, this can be used to surface information about the logged in patient without the model needing that information in its own context. And so essentially, you're enriching this business model. So what we end up with is essentially three different steps here. A user logs in to the application. They would then request a session with this new AI doctor, maybe in the form of a chat. And this doctor is going to understand Acme, but it's not going to understand this patient directly. And so what this application is then going to do is use the context of the logged in patient to query the vector database. Essentially, it's going to look for additional context it can supply into this model. And it's going to use the patient ID to ensure that we aren't leaking information from other patients into this model. It's also going to help the model prevent hallucinations because it has the right context for that patient. And we're just going to return the results from this database that match the context in which this user wants to query their health records. And so we're going to get this information back from the health record database and inject it into the model as context. And so what this means is we now have a user who successfully logged in with a chatbot which is enriched with the context of the logged in user. This essentially helps us ensure we're still within our regulatory frameworks. We're not breaching any of the compliance that we need to handle these sensitive records. We're not giving that information directly into the AI as we train it, but feeding it in incrementally for the session of the logged in user. Now, all of this sounds great in terms of preserving the platform, upholding the customer experience, and allowing Acme to scale. But there are a few things that need to be true for this system to operate in its intended way. And a lot of that has to do with latency and interconnection. Essentially, all of these systems, the application that the user logs in with, the databases that it's accessing, the AI doctor, which is going to ultimately be referring to those records, all need super low latency. Essentially, the customer experience is directly tied to that latency. And so we want to ensure as low latency and as streamlined processes as possible. And so we need this application to be in very close proximity to the infrastructure that's being provided by Grok. Now, assuming all of that's true, Acme can then go and prove the value of this platform. The idea being that they might want to see an overall reduction of 80% on the load to their human doctors. So maybe they want the AI to handle 80% of the trivial requests, essentially freeing up the human resources for those cases that need it. Now, with this in mind, maybe Acme wants to look at the future of their platform as well. This is great for a proof of value. They get access to the latest GPUs, infrastructure everywhere. But there's a chance that as this platform grows and scales, and as these data pipelines also grow, maybe they want to be in more control of this infrastructure themselves. And so there's always an option later down the track to build this AI infrastructure, both for training and inference, inside of their existing colocation environments. And that could make sense once they understand that there is real ROI to their business and that they can achieve the things they set out to achieve. Now, it's also not quite that simple because building and maintaining this infrastructure does require specialist full-time employees who know how to build, run, and maintain AI systems. Of course, everything to do with data science and the things that go around staging, modeling, and training AI systems. Now, with that in mind, Acme can go down this path and essentially see if this thing that they want to build around an AI doctor can deliver the value they want. And this is true for a lot of customers who operate in this vertical, but also in every other vertical as well. So we see distributed AI augmenting the experience for a number of different customers. But there's three things that have to be true for this to be a success. The first is to give careful thought to how data lives inside of this environment. As we see here, we have various data sources, and their interoperability becomes critical, especially as we want to deliver value across the enterprise chain. The second is going to be all around the network. Network for both moving huge volumes of data into training pipelines, and the network that's going to facilitate the real-time interactions between elements of inference systems inside of the AI landscape. And the final one is the ecosystem. AI is such a rapidly evolving space from both a hardware and software perspective, and access to the latest technology is going to make or break a lot of these initiatives. Now, I know we had a very heavy focus on healthcare here, but as I mentioned, we see this manifest across all of our different customer verticals. If you have any questions around how distributed AI could help solve real business challenges for you, please feel free to reach out to us here at Equinix, and we'd be more than happy to help discuss those challenges with you.